Hello. Hello, everyone. I'll wait just a little bit to get going. Let everything percolate through the tubes. How's everyone doing? Hello, DCD. Hi, Beata. It's quiet, which is nice. I might have to turn the AC back on. We'll see. I guess we could get going. We are right on time. So how am I showing tell progress? Yes, progress. Slow and steady wins the race, apparently. All right, let's get going. It looks like everything's working. Hello, Holly. Thanks for stopping by. So this is a deep dive. My name is Scott. I do programming for Adafruit. Adafruit is an open source hardware and software company based out of New York City. I live in Seattle, so I work remotely for them out of my office here in Seattle. You can see the window cam here. Sun's kind of out. I did just turn the AC off, so we'll see how warm it gets in here. I might have to turn it back on, but it's also not super warm out. It's just the sun coming in, I think, might roast me a little bit. We'll see. So Adafruit, open source hardware and software company based out of New York City. You can purchase stuff from them at adafruit.com. Purchase some hardware there. So what they make is these. One of the things they make is this printed circuit board stuff like this. This is an RP2040 Feather. So it's a microcontroller, which is a little tiny computer that's placed onto the circuit board, which is like a bunch of wires kind of like all embedded in the board itself. And then they have standard kind of like form factors for different boards so that you can put different boards together and do different projects. So adafruit.com to purchase stuff there. They pay me to stream every week. And they also pay me, well, primarily they pay me to work on CircuitPython, which is a version of Python designed for microcontrollers like that one. It's designed to make it really, really easy to get started programming on microcontrollers and like hardware devices. So I primarily do deep dives around CircuitPython, which is written in C. So it's a lot of C stuff. However, the last few weeks, I've been circling back to another project called CircuitMatter, which is actually a Python. It's all Python code, and it's an implementation of the Matter IoT spec. The Matter IoT spec, if you've been following along, is an exhaustive coverage of how you would make an IoT device that's secure. There are a lot of layers to it, but they're meant to be hidden from the end user, the person that bought a device and just wants to use it. So you may have gotten a device that has something like this QR code here that has a passcode embedded in it and some information so that the phone that you take a picture of this with can initiate what is called the commissioning process, which is the exchange everything you need to know so that next time if the device power cycles or something, it can get back on without any problem, without user intervention. So it's complicated under the hood, but kind of like CircuitPython from the outside, it's pretty simple. So we've had the goal of bringing Matter to CircuitPython, with the hope of making it really easy to interface custom hardware devices, so sensors and lights and stuff, with your kind of standard smart home ecosystem that you usually get via like Apple or Google or Samsung. Those are the big companies that have come together to kind of form the Matter spec and come up with it. So they've done their homework. They've done there's a lot of I's and T's to dot and cross when doing the spec, but generally we should just be able to, as an end user, should be able to ignore that. Hello, 232 Nate. I should say deep dives typically run about 2 hours. I should be able to do that today. We'll see. If folks have questions, we've got tons of time to answer questions, so feel free to ask them. I'm going to continue working on CircuitMatter today. It's getting there. So to recap, my approach with CircuitMatter is there's kind of two things in play. There's one, like pretending to be the device, and then also being the then there's the commissioner or administrator of the network. And so I have both running on my computer. The device stuff is what my implementation in Python, and then I run a command and it tries to commission and talk to my Python code from kind of the standard administrator code that is probably used in a lot of these like corporate devices. So that's a really good, like, it's a good approach when your spec is gigantic and you don't know what to do first, is basically like, just see, right? Like, what is the first step I need to do to get things talking? And then what is the next packet I get? Has been my approach. And we've seen a lot of the layers throughout the previous deep dives. To kind of recap, the very first thing that happens is there's a thing called MDNS, which is a way to discover devices on your network. The most common uses I see of it are like printer discovery and like Apple TV discovery, that sort of thing over your network, where there's broadcast packets that are happening over your local network that are saying like, hey, anybody know this thing or that thing? Are you this? Are you called this? Are you called that? So there's a certain way, or a certain, if you look in a Wireshark, it's like questions and answers, because like that's kind of how DNS works. But so the very first step to the Matter stuff was to be able to reply and say, hey, I'm this device and I'm trying to be commissioned. And then once that happened, we got a message and we needed to parse that message and figure out what it was. And it turns out the first step there, once you're parsing messages, is to, well, you have to parse messages, and then you have to parse this encoding called TLV that is all over, is used in a bunch of places. So that gives you like, there's a message outer wrapper, and then that's carrying a TLV structure that is more details about what you're doing. And that like inner structure is the thing that gets encrypted pretty early on. The outer structure is never encrypted. From what I can tell, it's just the payload in the inside that ends up getting encrypted. So once I get parse those inner messages, there's a sequence to use the passcode that either you type in manually or your QR code carries for you that is used to generate like initial encryption keys, and then your what is called a passcode authenticated secure exchange or something. I don't know. I forget what it stands for. PASC. So you get like a secure channel going, and you're encrypted, so you can do more things, kind of more trustworthy. And the next thing, this is kind of what was I working on it last week, or did I do it earlier this week, where once you have that passcode encrypted secure connection, now it asks you some details about like, what kind of device are you? And then it asks like, hey, do you have a certificate? And I guess I did do this earlier. Connecting via Wi-Fi. Yeah, correct, Holly. So there's two primary ways to be a Matter device. The first is just Wi-Fi or just over the network. So Matter is built on top of IPv6 UDP. So I'm actually implementing it in cpython using just standard cpython sockets. And then what we'll have to do at some point is implement all the things that I needed in CircuitPython as well. But right now my focus is Wi-Fi. The other way that it could work is over Thread, which is a lower power kind of like IPv6 transport. But there should be a pretty standard like layer that you could put there where it's like, it's either sockets over Wi-Fi or it's sockets over IPv6 or over a thread. And like everything above that should be the same, in theory. We haven't done that yet, but in theory. I think some of the like the MDNS stuff is specific to Wi-Fi. So we'll see how that changes once we add thread support too. But right now I'm kind of like, I'm trying to slim down what I'm trying to do. I'm trying to be just a Wi-Fi. I've already established the Wi-Fi connection, and I'm powered, so I'm not worried about like battery power at all. And in fact, I'm actually on cpython now anyway. But my goal, my first target is to be, I'm a plugged-in device. Like if you have NeoPixels, like if I'm trying to be an RGB light, you're not going to be on battery power probably, right? Like you're probably just plugged into the wall. So you're already on the Wi-Fi. We have a way to get you on the Wi-Fi with CircuitPython already. So you don't have to worry about getting on the original network, which they have a separate. So if you've ever heard BLE associated with Matter, there's actually like this, there is like a pre-step to what I just talked about that may be getting you bootstrapped onto the Wi-Fi network via Bluetooth Low Energy, but that's the only time BLE comes into it. So I'm not doing BLE. I'm just doing Wi-Fi right now, and I'm trying to be an RGB light. So I'm not there yet. It still hasn't asked me like really what are you and can I start interacting with you as a light bulb. I'm still working my way through this commissioning process. So maybe I should just show you my desktop as I can show you what I've added. Because I did a lot of, I was like, I felt like yesterday I got a lot done, and then today I did not get that much done. But I had to remind myself that I spent a good chunk restructuring things. As things, I was telling my friend this last night, like, I usually start in one file, and then as I have pieces, I split those pieces out into separate files. So, and that's even true if you go back and watch last week's. I now have like a clusters submodule that has init and core, and then I have case, which is, I'll get into in a sec, I guess. Certificates, crypto, data model, exchange, interaction model, message, paste, protocol, session, and TLV. So I have a lot more files split out now, which is good because my init.py is actually now only 443 lines. And it's mostly just actual session stuff. So, and all these yellow ones are like, you're not actually using this anymore because you've moved stuff. What else should I say? So I got the paste stuff working, and then once I got the paste stuff working, once you have a secure channel or connection, there's also like message counter numbers and deduplication and retrying. The retrying part I don't do yet. But you end up in this world where you're doing an interaction model. So it has, I should show. So I'm trying the Zen browser, which is based on Firefox. Let me just pull up the diagram again that I showed last week, which is down at the bottom here. So this is what I was talking about, where like Matter is really built on top of UDP. I haven't run into TCP yet. I don't know what they use that for, but UDP here. And then in terms of application layer, like the message framing and routing I'm working on. Security is like all of the secure channel pace, and the other way to establish a secure channel is case, certificate authenticated session establishment or something, I don't know. Action framing, I'm not sure what that is. But the two things that I've worked on in the last few weeks is like data model. So they have this data model of what does the /* prefix in Sublime. I think that's the file type icon. I think that's what it is. So it's saying like it's code, maybe? I think that's the file type icon. Thank you for the question. So there's this data model, which is like this notion of clusters, and clusters have attributes and commands. And then the interaction model is messages that are telling you kind of how to interact with the data model. So it would say like, hey, I got this message in that says I need to call this command, or I need to invoke this command, or I need to like read or write this attribute. The things I've run into so far is like, it initially does some attribute reads, and then it does some command calls. So I've got like the interaction model plumbing working. And I found, when I was doing that, I found more encoding issues with the underlying TLV stuff. So I did have to like, one of the challenges I found with the interaction model is that there's a few structures there where the type of the thing in the structure is not known. So attributes and commands also have types associated with them, and you need to pack them into like this one field of an interaction model structure. So there was issues I was having around like I had to split how parsing for TLV went and blah 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 blah. But anyway, I feel pretty confident like the reading attributes and the action calling or the command invoking is working. And then once I got to that point, so I have a secure connection via passcode. I've got the command invoking working, and now I actually have to implement the commands. So I moved that where that happens today into this clusters core. So this is like implementation of things. Implementation of core clusters that you'll always have. So for example, general commissioning cluster has this basic commissioning info attribute that gets read. So this sets what that is, and then when an interaction model read comes in, it slurps it and packs it and all that stuff. It's kind of like a nice abstraction where like the interaction model, when you're implementing the data model stuff, you don't have to worry about like what I think of as kind of like the remote procedure call glue. And then there's two commands, arm failsafe and set regulatory config, that happen. And I actually just say it worked. I don't actually do it. So arm failsafe is like, I think the way that I think about it more is like, if you've ever done database stuff where you say like, you're doing more than one manipulation of a database and it doesn't actually happen until you commit it. That's kind of what arm failsafe is doing, is that it's saying like, I'm going to do some things within a time period, and if I don't manage to do it, don't like just expire and don't make any changes. So that's kind of what arm failsafe is, and it's related, but I'm ignoring it for now. I'm just assuming it happens. I'm ignoring a lot of error checking and things too. So I should say, I am not trying to be a certified device. There is a way that you can say I am not certified. I'm a homebrew device, and then like your phone should give you one extra prompt that says, do you actually want to add it still, even though it's uncertified, and you can say yes. So I'm not being as rigorous as I would be if I was trying to make a library that was certifiable. I hope somebody comes along and says they want to certify it, but that's kind of not my goal. The other context is that, and I mentioned this on the deep dive last week, I am expecting another baby. I have a toddler, and we have a baby on the way, and that baby comes in 4.5 weeks by the due date. So I'm up against a bit of a clock trying to get kind of like this, what I think is like a vertical slice, like a full, like I can turn a light on and off demo, even though I haven't like handled all of the edge cases and things. So I'm trying to get to that point where I can do light on and off before I go on leave for a little while. Most of my leave will be later next year, but I will take 4 weeks once the baby's born. Okay, so 2 commands that get called. We just say, yeah, that worked. We don't check it. We don't do what we should actually. I ran into, so actually, let's just keep going. Congratulations. Thank you, Holly. I'm excited. Yeah, excited to be a dad again. I will have 2 kids. So then once you do the general stuff, you get into this node operational credentials cluster. So now this is the heart of the commissioning stuff. So here's some state that we'll see in just a bit. But first it can request a PAI, which I don't remember what it is. It's an intermediate signing certificate. And then the DAC is the like lowest level certificate, device attestation certificate. So this is the certificate that is used to sign information about whether you are a proper device or not. Hi, Dinkelberg. So first it asks for like the certificate chain stuff to verify against, and then it has an attestation request. So this is when you take, so CD is your certification declaration. So this is the thing where you either certify that you're a proper Matter device and it's signed by some keys that they have after they've tested your stuff, or you use their test key and say that you are not certified. You still have to provide this thing that says you're not certified, kind of in the same flow. And there's cryptography around it. So there's a nonce, which is like, I don't know how you actually term it. I'm not like really cryptography knowledgeable. I kind of play one on TV, I guess. A nonce is just like some random bits that you've agreed on to use in some computation. So what we can see is that we have this attestation element structure that is actually defined up here. It's a TLV structure. I don't know what ROT 13 is. So we encode this TLV structure. We append an attestation challenge. So this is something that the attestation challenge, the secure connection establishment, you need a certificate to say you don't own a certificate. Yes, as far as I can tell. Yep. So when you do the process of getting a secure connection, you have 2 pieces of it. You end up doing math so that you both have the same secret without having conveyed the secret to each other. And then you derive some keys from that. And when you derive keys, you get extra bits. And so the attestation challenge is something that you've held onto so that you can use it later. So that process kind of gave you this extra bit. So this attestation challenge is extra bits that you both computed separately in this process without sending it back and forth. So you add that to it, and then you sign it using your DAC key. So you have this private and public, you have this private DAC key that you use to sign it. And you've also sent the public version of that so it can verify against it as well. That's how you know that like this stuff hasn't been faked. And then you also look at the CD itself, and so DER turns out to be an ASN1 encoded. It's all certificate encoding stuff, which I had to learn because one thing I did this week is I wrote this certificates.py, which generates a certification declaration. So fills out all of the TLV stuff and does some key signing, and then it does some DER encoding to generate it. And then it loads the file up. So yeah, I've been in certificate land, which is why the deep dive today is CircuitMatter is certificates. For both the PAI and the DAC right now, I'm just using them straight out of the test. I'm just using test versions. Where was I? I was in clusters. Okay, so that's what attestation request is done. And then CSR request. So this is a certificate signing request. So you're creating a new key. Certland is a great place to melt your brain. Yeah, my brain's been melting. I was like 4 o'clock rolled around. I did like, I don't know, 5 or 6 hours of work, and I was just like, I made good progress, but then it was also like my brain's fried. So I think I've gotten through most of it. I have at least one thing I want to do before I leave today, so we'll get there. But just kind of walking through what I've been working on, and we don't actually need this anymore. So certificate signing request. This is like, okay, I'm generating a new key. I'm going to keep the private key to myself, but I'll tell you what the public one is. And then I need to encode the request. I need to, yeah, so here's the public key of it, putting it into the DER encoding stuff. Blah, blah, blah. And then I sign it. I sign the certification request info using that new key. And then I also give it more information. I give it more information, and then I actually sign all of that itself with the DAC key that we talked about previously. There's like so many different keys and certificates. It's kind of wild, which is why I say that like there's all these layers to all this. So that's the certificate signing request. It gives us a root certificate to consider trusted. And then we have this add knock call, which is it's node operation credentials or something. So this is it giving us more certificates back. So it gives us a knock and I don't know what it stands for, intermediate something. Another certificate. So, and these are encoded using a TLV structure that kind of mirrors regular certificates. So I added that decrypting as well. I don't know if I talked about how, so this is a TLV structure, and I'm giving it, the decode arguments right now are the control byte and then the rest of it. And the reason these two are split is that if there's a tag, like the thing that's decoding it doesn't need the tag that might be between the two. But in these cases, they're not. So the knock should include the public key we gave him before, and now we save it, we store it. So it's told us like what the FabricID is, what our node ID is, what the vendor of the thing that we're talking to is, which is kind of interesting. Then it says like, keep track of this. These are the keys, blah, blah, blah. And then one thing that was interesting is like, oh, like I'm through most of the certificates now, because the next step, what it does is it wants to switch from this passcoding authenticated session to a certificate session instead. And the reason that is that's the primary way that you'll actually be talked to or talking with is via like your certificate stuff. So I knew I was going to have to do this work because I knew that that was the case. It's so complicated. So like okay, you're changing the MDNS stuff, and your instance name is this like compressed FabricID, which you use this like key derivation function to do by like encrypting this compressed fabric string. It's just, it works. I got it working, which is nice, but it's just like there's a lot of work done so that like things aren't obvious if you're just looking at the raw network traffic. Let's see. So at the end of this, it's now trying to talk to you again to establish a certificate session, not a passcode session. So going back to init, we can see in process packet, here's the P stuff is basically the passcode authentication stuff. And now we're getting into case, which is the certificate stuff. And the first message we get is the Signal1 message. And maybe I should pull it up here. We'll have to remember where I'm at. So if you just go to the top of this section, so certificate authenticated session establishment. Here's the things we're trying to do. What I found interesting was this. So the initiator, which is not us, sends a sigma 1. We reply with a sigma 2. And then they send us a sigma 3. And then we say, yep, that looks good. Sigma finish is actually not a different type. And then there's like this other protocol for like resuming one, which we're not actually doing yet. Message framing. And then we are in this sigma 1 thing. So the initiator, so these steps we don't need to do because the other side's doing them, but basically generate a random number, pick a session ID, generate a key pair, blah, blah, blah. So on receipt of message 1. So this is what I was working on today after I restructured things. Because now I'm getting to the point where I got to maintain more state, and pretty soon I'm also going to have to get in the world where I'm like saving and loading it. So for example, if I got all these certificates now, I could actually like save those and load up and like skip all the steps before, like, because we're almost commissioned. So pretty soon I'm gonna have to figure out or reorganize so that I can like save and load state from the disk. But I'm not quite there yet, because there is like a commissioning complete call that happens apparently over the case session instead of the password encoded one. Okay, so I've gotten the sigma 1. I actually do this check, and then okay, so the responder shall validate the incoming destination ID. So what you do is you traverse all of the node operational certificates that you've got, and you generate candidate destination IDs based on this procedure. You compare, you have to find the entry that it matches, and then if there's no match, then you say like, hey, we don't actually share anything. Like, I don't know what you're talking about. Otherwise, once you've matched the destination ID, you've found like kind of like the certificates that you need, which we'll get to. But the step I'm on right now is I need to, and the reason I was kind of reorganizing things was like, okay, now I need to like, I may not have even saved the information that I need, but I need to be able to generate candidate destination IDs and figure out if any of them match. So the thing when I loaded this up that I was in this destination identifier phase, and I was like, oh great, like when I get the knock thing, I'll just generate it and I'll store it. And then I realized, you actually need like the random values they sent you in that sigma 1 to generate them as you need. you can't just do it once because it's got this random crap in it, which is great. So are there any questions about that or anything else before I get to the like heart of it? So what I'm going to do is that there's a sample here of how to, given all these things, this is what you get out of it. I'm just going to verify that my code is working there, and then I've got to have the new inputs. But are there any questions? I know that's like, this is why it's called deep dive, because we're deep in the weeds, but people are going to have opinions about which weeds to be in. So this destination ID stuff is the stuff I'd like to get done before I call it a weekend or call it a week. Yeah, and even if you say that you're not certified, going back to Dingleberg's comment about a certificate, there's still lots of certificates for encrypting and decrypting things. I'm watching I've got one of these sensors here that tells me how hot it is inside here. So I think I'm gonna, this 78, and this face definitely turns happy about the time where it's like, okay, yeah. So I think I'm gonna have to kick on the AC here soon. Because when I started it was 74 and now it's 78.1. Yeah, in fact, I'm gonna do that right now so that it doesn't get hot beforehand. This is why I get sleepy too. So sorry, it's gonna be a little louder. It's gonna kick on the compressor. But it means I've got no clue what you're talking about, so no questions for me, Dickelberg. Yeah, sorry about that. Again, like ideally you won't have to worry about it. Hopefully it'll just work. Anyway, but this is like, I'm definitely not super comfortable. Like parsing I can do, but like being in these weeds about certificates and keys and stuff is like not a place I'm normally at. I haven't done a lot of it, but luckily like the spec is, like there are some inconsistencies across sections in the spec, but generally like they are quite prescriptive about like what you should do when. Like literally like step 1, do this, step 2, do that, step 3, do this, which is nice. So first let's just validate. So I have a case file, and I'm just gonna take the values out of here, and I'm gonna do this, and I'm gonna make sure I get the right result. So I'm gonna take this number, and this is gonna be the FabricID. So I'm gonna add the FabricID. And this is something I did for, I did it for the other DER, was it the DER encoding, like the attestation challenge stuff? They also had examples in the appendix that allowed me to validate that my code was right. Node ID. I don't think that's the case in here. Epic key value. Huh. Derived operational group key would be that. This says initiate random root public key FabricID. Oh, okay. Right, so this is... I don't know. This is a good way to have an understanding what the heck they're talking about too. This is just making up stuff. I don't think it has my, yeah, it doesn't have my paste contents. So the prompts that you're seeing are from GitHub Copilot. So I don't know why it's giving me do that again. I do really like GitHub Copilot, so. And then I'm going to print destination ID. Too many quotes. I really don't like the editors add extra quotes. It's kind of annoying. Destination octet. How did you give the matter specification to Copilot? So I don't. It doesn't have the actual spec. Although sometimes I feel like it does have some knowledge about what comes next. But one thing I'll often do is like I did a bunch of these structs in here. So all these structures. And what I do is I just take the spec. Let's see, how could I do this without cheating? I don't know what context it has. Actually, you know what? Let me show you an example. I'm sure there's a cluster type that I don't have yet. So let's just add a cluster. So there's this descriptor cluster. Which I know that I'm going to have to implement, but I don't yet. So let me show you how I do this as a demonstration of how I use GitHub Copilot. So clusters are in data model here right now. So this is not the implementation of the clusters. This is like defining the shape of them and the types. So basic information cluster. If we find it here, I think it's actually under, yeah, so service and device management cluster. But imagine that I want to add the descriptor cluster. So I'm going to just add that, and I'm going to add it before. So I'm doing descriptor cluster. It's a cluster type, so that was GitHub Copilot. And the cluster ID. All of this is a lie, so I'm going to delete that. But it is 1A, I think. Oh, 1D. Cluster ID is 1D. So you do have to be pretty eagle-eyed to make sure that it's not, it's numbering things correctly, for example. So here's one device type struct. So I'm just going to copy this, copy text, and I'm going to paste it in here. And I'm going to comment it. And I'm going to say, okay, I want to have, no, that's not right. Device type struct. And it it filled it out for me. So it gave me 2 int members, 1 octet 4, 1 octet 2. So if we look here again, usually I have these side by side, but I have like only a portion of my screen that you're seeing. So device type, revision is a uint 16 with a minimum of 1. Revision, it's an unsigned 2 octets, so that's 16 bits, and a minimum of 1. Minimum, I'm not sure I actually take as a parameter, but it's not being highlighted, so I think that's probably right. And then device type ID, I don't actually know what it is because it's behind this thing. So let's just do a quick search for that. So here's data types, and it's a uint 32. I don't know why there's another ID. I don't know what that is, but it's 4 bytes. So when we go back here, you know, it's probably an enum, and so we may want to switch it to an enum later, but for now, this is fine. So this is my process. So now if I go, how do I go back? Descriptor, so that's data types. There's only one data type I have to worry about. Now I have attributes. So say I want to do all of these attributes. I'm just going to highlight it. I'm not going to worry about structure, although maybe I do want the headers. So I'm going to do the same thing I did last time. I'm going to copy it, and I'm going to paste it in. It's all this like unstructured stuff that came out of the PDF. For now, I can delete this. What I realized is that if I'm doing something similar, like if I was doing another struct, I would leave this as like clues to the copilot that like this thing matches up with that thing. But here we're doing attributes. So now I'm going to say, and again, I would usually have these next to each other. So I'm just going to start what I want. I'm going to say device type list. Device type list. And it auto-completed it. It says it's a list attribute with the ID of 0. That's the wrong thing. Server list is next, and it's of cluster IDs, which I'm going to have to check again. But server list, client list. I don't think, that doesn't seem right. Oh, it is right. Server list, client list, parts list, tags list. Parts list, tag list. And it numbered them automatically for me, but double check your numbers. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. I forget what these qualities are. This is like super vague. MCX says, how does one turn a PY file to an MPY? Take a look for MPY cross. You can download it, but I'd probably go on learn.adafruit.com and just search for MPY cross. And so this tells you what the lists are of, which I don't know if it matters. But basically that's kind of my approach, is like if it's a table of things, I will just copy it, paste it in, and start kind of queuing it with what I want. That's how I do it. Sometimes one thing you can do is if there are descriptions in that, some of these, you'll see some of these I do have comments. So sometimes it'll be eager to just do more code, but you can actually do the comment, and then it's pretty good at picking out the comment bit as well. It fills the role of like, I could write a script to auto-generate all this, or I could just copy and paste this info and like let the LLM do the mimicry. Works pretty well, especially if we're doing all this like structured data type stuff. It's worked pretty well for me. Probably a smart fridge. Yeah, we'll see if we see any smart bridges. I don't know. Okay, so let's get back to, if you have more questions, please ask them. But that's the gist of how I really find, I find Copilot really helpful for that, and I find it really helpful for just, I want to print out a debug print here, but it's smart enough to know a little bit of context about like what variables and stuff you have, so it can include like prints of variables and things. That's pretty handy, and it like often knows like the structure of like doing the print statement and things too. But yeah, so that's kind of what I've started doing, is just copy the data, mark it as a comment. The other thing that I've like rarely started doing, but you can do more, is you can actually say like convert a parts list to a client list. Something like completely kind of wild, and then you can just see like, oh, it just passed it, but like it kind of gives you like, one thing you could do too is you can kind of do like human readable prompts or information to the LLM that way as well. So yeah, that's, I'm sure I'm gonna have to get to this descriptor cluster probably once I'm commissioned. It's gonna ask about this. And then I'm gonna have to figure out what device type actually is. But first we gotta get our secure connection going again. And so I'm gonna do Python and CircuitMatter dot, where did I put it? I was doing it in case, right? Yeah, so I want to call this code just to like make sure that I understand what's going on. Can I do B's? So another thing I like about Sublime can do multicursors, so I have the cursor in 3 spots right now. It's kind of neat. I'm not worried about formatting right here because this is just test code. I'm going to delete it soon. Anyway. I wanted to figure out what the identity protection key that it uses is, but it's not actually... It's actually confusing me. It let me turn off the bar at the top here, and I don't know how to turn it back on. I kind of like hate that. I also don't understand why there's no back button. I've said this before on Deep Dive. Oh, here we go. Show menu bar. Like, there's this back thing here. Like, why didn't you have just like... If you have links in something, you should have a back button. I'm like not a great keyboard shortcuts person. There was a defaults. Okay, so this is all the descriptor stuff. I'm trying to get back to the case thing. Here we go. Do I want the 4A or the 9B? The IPK. I have to derive something. So this is what it says I derive from it. Let's try that, and then we'll figure out how to get that. there. So we're going to call destination, compute destination ID, all these things. This needs a B in front of it too. Let's try it again and see what we get. Bytes like object required, not a string. Oh, did I not actually? Let's try it again. I assume previous page, so Gordy says, how is back different from previous page? I assume previous page is just like literally the... Oh, no, that's not previous page. That's the search. I think this is what you're thinking. It's literally like just going page by page, not back. Like if I click a link, I want to undo that link click. That's what back is. Defaults when adding stuff to the toolbar at the top. Acrobat seems not to have a back button either. I miss it too. This is the way the Olama project has models that help with code too. Yeah, I wanted to go down that rabbit hole, and then I realized it's like way more cost effective to just use Copilot. I have lots of rabbit holes I want to go down. I was talking about school funding as top of mind recently too, and then I'm about to have a baby, and it's like all gonna go out the window. Okay, Tyeth had a matter question. So random matter question. I got the impression you cannot define custom things like services and characteristics in BLE or even custom devices. So unlike lights plus washing machines, instead add support for something not yet in the matter spec. Is that about right? That is my understanding, although I haven't really gotten to that point yet. Because we're trying to interoperate with like Google Home or like Apple Home, like those things will tell you exactly what device types they work with. And device type is kind of like code, or it's an outer level thing that says like, if you are a washing machine, you have these clusters. So I'm like, that's why I'm not there yet. But yes, I think like it's not going to be completely freeform like theoretically BLE is. We're going to be working within the spec only. But in practice, you don't see a lot, because a lot of the value we have for our projects in CircuitPython and Adafruit is that we interoperate. Like give USB, for example, like we don't really have any like custom USB device stuff, even though it does exist. Like we just travel down this happy path, and like if you need custom USB stuff, you actually just do like a standard USB sensor. You do a standard USB serial thing, and then you do custom stuff over that. I wonder with gas sensors, does each individual type need to be defined in the spec, or is it more like a gas type with the value in units supplied by the device? Yeah, so I haven't really gotten into that stuff yet. The clusters, I think they're, let me look at my downloads folder. I think I might have, yeah, so if we look at my downloads folder, I have core specification and then device library specification. So let's see what that has in it. So look, I actually have it up on, this is a air quality sensor. This defines conformance for the air quality sensor device type. What do you have? Oh, here's the ID. It is a simple, and it has a scope of an endpoint, which I don't really understand endpoints quite yet. And then it says, here's the clusters that you need, the identify cluster and the air quality cluster, and then all of these. So O is for optional. Hi, 3D Tech Guy. Welcome, welcome. And then there's a carbon monoxide, carbon dioxide, nitrogen dioxide. These are all optional. These are different cluster types, which I don't think. So this spec doesn't have the cluster types. No problem, MC Equipment. But if we look here, we have application cluster specification. So yeah, I haven't gotten here yet, but we will. So here's the identify cluster. The cluster ID. Oh yeah, this is like how you can cause it to blink and stuff to figure out what it's talking about. That's right. That's what identify is. Scene management, on, off, level control. So I think there is a way to derive air quality cluster, feature map, fair, moderate, very poor, extremely poor. Concentration measurement clusters. So this cluster shall be used via an alias to a specific substance. So maybe what I would do in CircuitPython is I have a concentration measurement cluster, and then you subclass it setting the different IDs. Right, so there's different ID codes for whichever thing it's measuring. And then it's got data types, enums, attributes, no commands. So this is all like data model, interaction model level stuff. And you can like subscribe to attributes and things like that I don't have supporting yet. But that's where we're going. Hopefully pretty soon, because I don't have that much time. But yeah, and then like these sorts of things I would put like in each set. They would each go in separate. They would each go in separate files, so that you only import the ones that you actually need. Yeah, this looks like that's how it works. We're not there yet, though, unfortunately. Gotta do this secure stuff. Oh, from hex must. Oh, geez. I just did all this byte string stuff, and now I need to do it as a string. So I'm gonna I'm using Control D to get my multi-cursor going, and you'll be able to see it here. Hi, Timon. As I got a lot of cursors, and I just delete all the B's. It's really been, Control D is like the only way that I've successfully used multi-cursor, but it's pretty handy. It's kind of like search and replace, except it's not search and replace. It's just like select all of the cases and then modify it the same way. Byte join takes exactly one argument for given. Well, that's because you need to wrap it in a container. Okay. I haven't seen that. I'm not going to worry about it. I got a result. It looks too long to me, but let's just see what it sad. Product attestation certificate. I'm like all in the wrong place again. I need to go back to commissioning. Commissioning flows. Oh wait, no, I'm not in commissioning. I'm in secure session establishment. Destination identifier. Here's the destination message, which maybe I should print out. Hey, it does start with DC35. That seems right. It ends with 4C53. Yeah, we got it right. Nice. All right. So now we just gotta like store all the inputs we need and provide them. Which should be a good task for the next hour or so. So if I just do, I don't think, unfortunately, I was showing how I, reply to Signal1. Oh, I got pretty far. Session 494. Oh, nice. Okay, so even though I'm failing, it's still getting the message and running my code. That's great. So the problem, a lot of the certificate stuff is not deterministic. It uses random. So the knock stuff here is actually failing with this invalid public key check, which I could just comment out actually, and then maybe it would get further. But then like when it comes to just parsing this thing, it'd be okay. My state's not going to be quite right. Let me see if I have this invalid public key check. Let me just invalid public key. Like the replay stuff just isn't going to work anymore, unfortunately. Because I'm not passing my like deterministic random all the way down into like the cryptography libraries, which maybe I should. I'll have to think about that this weekend. But I can also just run it live. It's not too much extra work to do that. So it's retransmitting because it crashed. And this is not right either. So yeah, I wanted to do a private AI stack and get into that, but I lost steam pretty quickly. I ended up just shopping for GPUs. Hi, Axel. Instead, I just ordered another Lego set for me to get off my computer and put together. So I might do that tonight. It's nice to have something to do with my hands that's not on the computer. Especially when I'm getting a little bit more anxious about like the baby could come at any time. So having some outlet is good. Like Lego is a good outlet for me for that stuff. Okay, so we are in the Pi and then session. 232 Nate says, what Linux distro are you using? I like Arch Linux. I've used it for years. It's great. Although I do come from a Gen 2 Linux background where I was compiling everything. Yeah. Arch Linux is the answer. Session. What do I need to give it? There's the initiator random, which is a start. I might have to derive. You don't like Arch? Come on. Why aren't you sliding over? X. I really like rolling release distros. That's part of it. And this calls it the candidate. I try to like match their terminology too. Okay, so we need root public key, FabricID, and node ID. I've heard it's super hardcore. I don't feel like it is. I mean, the reason I like rolling release distros is like, well, one, I update all the time, which I do like, and occasionally it does bite me in the butt, but it is fine too. It's not like I'm doing like massive updates every 6 months. Yeah, I don't know. I like it. I never have to do something like really big. It's just like my computer stays as my computer and just evolves over time. Gordy says, I used to use Arch. My son is a programmer. Once he went to university, I switched to Mint. Yeah, I heard good things about Mint too. Like, they polish it up pretty well, I think. I like using the latest things. And if you're not on a rolling release distro, you gotta wait longer. Okay, so let's see what I want. Oh, you know what? I think I want to enumerate over the fabrics. Because I am fabric. Yeah, my computer has roots that go back to like 2007. Yeah, and like I can bring my hard drive with me and like even update CPUs and stuff, and it's still the same. Got tired of being told to do my own research. I find that Arch Wiki is very helpful. That's kind of where I start. So I think if we look at core fabrics, new fabric is, so there's a fabric ID and a node ID. And I chose to mimic the capitalization in the document, in the specification, even though it's kind of non-standard Python. So it's kind of like, if it's a structure that is defined in there, then I go by it generally. Ship of Theseus, but still has the original hull. Yeah. I like Arch, but have been using Debian. Also, I prefer Sublime Text Editor too. Yes, I like Sublime Text Editor. I've been trying to try Zed again, because they announced their like AI integration. And I'm curious about using AI to do more restructuring. But I haven't gotten there yet. I'm happy with Copilot. Okay, so we want Fabric ID, Node ID. And that was in session. Actually, let's just do it in here. Arch is like buying a car from IKEA, but with no instructions. You're gonna have to build everything. Ubuntu is enough for me. Zed is Z-E-D. I have it. The Zed text editor is what it looks like. the current version. Too many errors, stopping now. It's written in Rust. They like to think that it's fast. The Arch wiki is quite good, and once you build it, you don't need to build it again. You just buy the car once, and you get it set up how you like. And then maybe you like swap the mirrors or something. I don't know. Okay, so let's self dot trust roots. So this is interesting. I don't know. I'm not sure this is a thing. I might be a copilot makeup, and then I'm like, oh, but do I like that name? So if we look here, I'm curious. Ah, interesting. So it has trust roots. I don't know if trust roots exists, but let's take a look. Pending root cert. I don't think it does, but I also don't. I don't hold on to it yet. Oh, you know what? Maybe it's in the data model. Let's check there too. It's possible I haven't implemented it yet. Node operational credentials cluster. Knox fabrics, supported fabrics, trusted root certificates. But that's only going to be the public key. Oh yeah, I don't go to the Arch community at all. And remember, I was also coming from the Gen 2 world where you literally built every package. And you know what I did before that? I was a teenager at this point, but like my introduction to Linux was the Linux from Scratch book, which is literally like calling, configure, and make for every single package. So like going from that to Gen 2 was great, and then going from Gen 2 to Arch was great too. And I just like, Arch has gotten more popular than Gen 2 over time as well. Like when I was in college, I did this whole project of mine where I tracked like how out of date every repository was, like how closely they kept up with upstream. Like that's kind of what I want. I wanna have the latest and greatest thing. Clever says, I also learned Linux from LFS. Yeah. I finally got it booting, like finished the book, and was like, wait, how do I have to do this for all this other stuff, like KDE? I was like, oh no, I'm not gonna do that. And then I found Gen 2, and I was like, I'm gonna do a stage 1 Gen 2 install, and like compile my compiler, and I learned a ton. Now I'm like, Arch is fine. I don't think I actually want this trusted root certificates, because I suspect that it's just the public keys. I think what I'll do is I'll actually have, let me do a secrets. Let me add like a secret. So I can add more stuff here. So self secrets. And then I think maybe I'll do, I don't know. Because I don't know exactly how I want to structure this, but let me get it working and then go from that. Secrets. In core, Pending public key. Pending root cert. Where is the IPK as well? Not here today. What is that trust root cert? Maybe we just say root cert, self root certs. Went from DOS to Windows to Arch. Oh, sorry, that was my Discord sound. I'll put it in my headphones. It's not in this channel that I'm looking at, so I will have to look later. We'll just have our root certs. That's the bit we need. And we'll have to figure out what the IPK thing is too. This has been my week, like detailed reading of root certs I. And then we'll just say it's IPKI. Destination ID, and let's do print here. Oh, come on. Let's compare the two. Is CircuitMatter going to be a CircuitPython library or an all Python CircuitPython integration? So CircuitMatter will be a CircuitPython library, but we will have some lower levels that we need to do in CircuitPython itself to support it. And that probably won't, that might happen when I'm out. Like I feel like I can try to hand it off and be like, here you go. We'll see. Or I'll do that bit when I get back. Although if it only runs in cpython, like there's still a world where we could do some projects on Raspberry Pi, which would be cool. Like we could totally start like on the single board computer side first. Identity protection key. So I don't know how, I feel like I heard that and then I don't remember where it's from. Oh, that's right. The octet string or group epic key would be provided in the IPK value field or in one of the epic key fields in the key set write command. The derived operational group key to be used for computation the epic key And then you take that epic key and you use the public key and the FabricID to generate an operational group key. Group key v1.0. Compressed fabric identifier. Oh my goodness. Let's see what I added. So I also have this group key thing. Group key management, key sets. Key set right. Self key sets. Append args group key set. And group key set has the ID, group key set ID, and an epic start, epic key of 0, which is what I want. So I'm going to cheat. I'm going to cheat a little bit because I know I want the first one. So I'm going to say I'm the session. I'm the session manager. I have the knock. No credentials. And I need to do this on a specific IPK epic key equals no credentials dot group key group key manager key sets. I know it's the first one. I should look through this. I don't care. Actually, we'll just call this key set. And then epic key is equal to key set epic 0, I think. Epic key 0. Is CircuitMatter free or paid? CircuitMatter is free. It is open source. You can go to Adafruit, github.com/Adafruit/CircuitMatter and grab the code right now. I guess I may not have a license in there yet, but, oh, I do. It's MIT. It's free. Okay, so what is it called? This is all easier when I'm not just using a part of my screen. Key set right. Epic key 0. Okay. That's what I want. Epic key 0. The problem is that I need to do the IPK key. So this is going to be, where did I find that? This. So I need to do crypto.kdf. Crypto.kdf. IPK epic key. The salt is the compressed fabric identifier. Thanks, Clever, for the link. Info and length. Generally, this is not. I'm gonna just do bytes. And we also need compressed FabricID, which we do know. I think we could just save it. I will just do key sets of byte 2. This is where I cheat it and be like, I just want it to work. So we have the compressed FabricID right here. And I'm just going to hex. Oh, you know what? I don't want it as a hex yet. I still want it as bytes. Self-compressed pens. We'll get it back out. We'll hexify it, uppercase it. There. Like in practice, like where we're going, or we need one. Let's try it. Knock is not defined. We received it. We were trying to reply, but then we wanted to print knock, and knock doesn't exist. Session 486. Darn, right before all the code we wanted to test. Again. Oh. The D is capitalized. You think node ID probably is too. Again. Got about 30 minutes left. We should be able to figure this out. Boop, boop, boop. Matter certificate found. Because the root public key root certs. You know what? I don't want the decoded version. I actually want like just the key itself. So I want EC pub key. And I could do that actually here. right, try it again. So this is the MDNS for being commissioned. And then you'll see int found. Oh, I need it encoded. Should I take it as ints? I don't know. Is it little endian? I think it's little endian. Let's see. Just trying to get this going. I'll get it committed and then I'll be done for the day. I recently started playing with some Zigbee hardware. Gave me flashbacks for trying to implement NDNS and they're like, oh yeah, good luck with that. Okay, now we're gonna get some bytes. Replay's a little nicer. 501. Darn. It didn't match. It should match. Let's do maybe in this case thing we'll print all the arguments. This is where it works out. Where Copilot can be really helpful for start over. Didn't match. Root public key started with an 04. I know what we should do blanks too. Where I make sure that all of the lengths are right. So what I can do now, or what I'll be able to do, is I'll be able to print. I'll be able to do that previous thing to make sure that like all of the structure of the things I'm providing is right. If that doesn't point me anywhere that makes it work, then I can find the place in the other code that's actually doing this too. It could be my key derivation function that is the problem. Could be that my compressed FabricID needs to take account of the different random bits. Maybe that's the case. Didn't match. 65, 8, 8, 32, 32. $65, 8, 8, 32, 32, and then if I run 65, 8, 8, 32, 16. 16. I have something funny. Let's see if that's it. This thing doesn't return the right number of bits. I think I've got to fix that. That was a problem. Or something else where I was giving it 32 bits and I needed to do 16 instead. So it still crashed. Hey! We matched. Timon says, have you seen the NXP MCX A and the MCX N series? They look super interesting, kind of similar to market as SAMD 21, with very rich mixed signal peripherals and quite cheap. Feels like a great fit for CircuitPython. I've been really missing something that's highly integrated like SAMD, but much faster and still low power. I have one somewhere because they were giving them out. I have not gotten it working yet, and I haven't looked at that recently. I didn't realize they were quite cheap. The other thing that's on my radar is this STM32G series, but it's hard to beat the RP2350, even though it's not quite as integrated. If you want to do a port, you already got tiny USB support. That's good. DCD says Match is a great way to start the weekend. Don't test anymore. Just check it in. MCX A is between 2 and all. Let's take a quick gander. I've been known to like shopping for NXP MCX A. Ooh, Cortex M33. A13 SRAM. I wouldn't spend my money or time doing this one. They are quite small. Oh, it doesn't have USB either. So I wouldn't do this one. This one, 48 megahertz is what the SAMD does too. It's probably a little bit quicker. This 128K SRAM is really not that interesting to me. Like, CircuitPython's better with more. 128 is still quite small. The A156, 180C temp sensor, UART SPI, I3C, full speed USB, 96 megahertz. I don't know. I don't know. Tell me why it's cheaper than an RP2350. Like, it requires external flash, but external flash is pretty cheap. The other diagram. Ah, well, okay, I see. This is just the 52 and 53. Oh, interesting. The lower numbers don't have FPUs, the higher numbers do. It also has a DAC, which is nice. Not so much RAM. FlexIO. I've always been meaning to get into FlexIO, but haven't. If you want to add it, that'd be awesome. Do they use the same SDK as like the IMX series, or would it be another SDK support? I was almost thinking you were talking about the analog devices ones, because they just made a pull request today for the analog device, the Max 32690, which I don't think is as cheap, but it's also like a meg of RAM. It's a meg of SRAM. Very bad analog peripherals. That's fair. I mean, Zephyr support, but there's also a Bear C SDK. Yeah, we would target the Bear C SDK. Zephyr is like taking two giant, like big CircuitPython project and big Zephyr project, and yeah. DSP coprocessor. That's the fastest one with 512K RAM. Yeah, I mean, then you're getting there, but now you can't make a cost argument, I bet. I don't know. I'm always happy to take more PRs for chip support. So I don't know. I don't know which. I got one of the. I have one of the MCX Ns. In fact, I have the MCX N947. I can see the box from here. I've got that dev board. They were giving them away. The ADC is excellent. Oh, and Cap Touch. I don't know. Sell Lady Ada on it. Yeah, I agree. Yeah, like ESP and RP2 don't have great analog support. I totally buy that. But then again, like, if you want to do analog input, you could do like an ADC, I2C DAC or something. Anyway, yeah. You have to really have an idea of like, okay, what can I do with this that I couldn't before, and make sure that you're not blowing your budget while you do it. How much do I have to do to respond? Both are terrible at low power. I don't know. They've gotten the RP2350 down quite low for low power, but we haven't added support to CircuitPython yet for that. Okay. We got this matching. You know what I should do? I think in this function here, not that one. This one. I'm going to call it a memory view too. Do I want it to be a memory view? Or do I actually want to create it? There. Now I don't have to do it. So in here, it's going to actually respect the length I need now. So it should still work. Matched, matched, matched. Protocol ID. I moved it to protocol. matching knock is I'm gonna need some more stuff, but I'd love to get to the point where if matching knock is none, this is a source of bugs. If you just do the like plain check, if I is 0, it will still say it's false. Yeah, I mean, sell 88 on it, Timon, and then you can have the support. All right, let's see if we get to the Sigma 2 not being able to be encoded, and then it's probably about time to. Spec 2 message 1 failed. All right. It bothers me that there are APIs that take bytes but don't take message views or memory views. No shared trusted root. So sent Sigma 1 and then received an error. Didn't match. Because the identity protection key is the wrong size again. What is that? What's the deal with that? Symmetric key length bits. Isn't that how we get the identity protection key? Am I assuming it's bytes? I think I'm assuming it's bytes. Yeah. Don't do float math, silly goose. Well, we got the error message back correctly. That's pretty good. Okay, we broke it again. Now we're being too aggressive. Somewhere we're getting it length in bytes, not bits. Hash length bits. Oh, come on. I'm close. I'm close, folks. I'm close. Where's my... Forgot where my... There it is. I know. Compressed fabric IDs. This is wrong. Bits. Clusters core. Checking the lengths has been a successful thing. Sent it. Responder random isn't set. Okay. We matched. Now we gotta fill it out. How bad is it? Responder random's easy to fill out. You just need some random bits. That is easy to do, but I suspect the other stuff is going to be a little much for finishing the day with. Let's see what it says. So we're filling in Sigma 2. We validated the ID. We failed correctly if we needed to. If the match was found for the destination ID, the match NOC, ICAC, and associated trusted root shall be used for selection of the responder NOC and the responder ICAC in the steps for Sigma 2. Encodes a Sigma 2 message, which is, yeah, so we have to do some more signing of this thing. Responder NAC and ICAC, which should be easy. Ephemeral public keys. Yeah, I don't want to do this. I'd rather shop on digikey for a good dev kit for this board, because I am curious. Generate an ephemeral key pair. Generate a shared secret. I will pick this up on Monday. So let's pull up merge and we'll get it merged. I like to, as folks know, I like to commit at the end of the day as my backup / I work open source, so that's cool. So you can see I took a lot out of init.py, and can I crunch this all up? I actually prefer the other view. Not gonna give it to me. Oh, it's so close. Okay, you can almost see everything. In fact, I could scooch it this way. The stuff on the left isn't as interesting. Okay, so here's me doing a lot of restructuring. You can see I have a lot more imports, and just trying to better organize the code base a little bit. There is a JavaScript implementation of all this stuff, but I'm sure they use libraries for all the crypto. I'm not going to worry too much about prints. Let's stage that. Stage that. There's the descriptor cluster we added. It's not actually doing anything. So we're going to have some formatting issues here too. This is just moving stuff. It's all recorded packets. And then here's the new files. So case, clusters, core, exchange, message, protocol, except we don't want the certificate declaration. Now it's going to check me. Let's do the formatting stuff first. If you don't stage it, then the formatter doesn't know, because it's worried about what you're going to do. Okay, so let's fix this stuff. TLV is imported but unused. Status report is unknown. I forget where I moved status report. It's in session now. So let's go back to init, and it's telling me TLV is not there. I fix it in 2 spots. Did I miss any more? No, it doesn't look like it. try again. Let me stage it. Those two things. Failed undefined JSON and undefined protocol ID. So that is in session. Need an import. My plan is to just store everything as JSON files. Yeah, this definitely has me understanding the crypto stuff a little bit more. And then protocol ID. Yeah, okay. Stage. Restructure. Destination. ID. These are bad. It's fine. It's signed. Let's just do one more check. See if we get where we want to get. Which we do. And it. Okay. This is where I'll pick up. I'm just pushing to main, so don't be surprised when it changes. Any final questions? I'm tempted to shop on digikey now. It would be cool to have better analog peripherals. MCX A153 is what it was. Evaluation boards. $15. That makes my price point. That hits my impulse buy. Is it a new product? It is. Oh, you know what? Timon, if you're still watching, you should email Lamore and see if she wants to do this as a new product introduction. Yeah, I think I found it. In stock new products. Exclude marketplace products. Hey, 150 new products. This is how I find the stuff to impulse buy. You sort by price. And it's funny, you get Adafruit dev boards too. Nucleo U083. I think I have that. Oh no, you know what? I don't have the U series. These ones are interesting too. They're M0s though. C0. Oh, the 156. Okay. Well, it should be here. Interesting. This IMX board from OMX is $11. Like, that's quite good. Shao RB2040, Metro RB2040. Here's the 153. Pro Micro. I don't need any more RB2350s. MCX C. Those are M0s though. Grow Vision. 156. Trinky. N236. And I have the what? N947? I don't know any of this. The U series. STM32U could be interesting too. Let's see, I'm still in the 25s. This is the one I have, the 947. Oh, and here's the A156. There's only 2 of those. Maybe I'll make an order. I wonder if they have any of the new ESPs while I'm at it. I saw this one just hit tiny USB, I think. It's an M7. I really love seeing all the different form factors. Yeah, ST's really good. They only have like 3 different form factors. They are definitely like, ST's got great dev kit game. G473. The G series is interesting to me. The bottom of the G series is pretty interesting. This is just a surface on module thing. Could never get into the Kinetis. So we're hitting the $50 mark, which is usually higher than my... This is an interesting form factor from these microelectronica folks. It's got this like edge, it's got this high density connector in the back, and they have a lot of different sample boards for it. It's pretty interesting. U5G, is this the one that has like a ton of memory? I think it might be. I think, so I just because I'm adding it to my cart doesn't mean I'm gonna get it, because this is, I have way more boards than I've ever touched. But that one's kind of interesting. This one's interesting. We don't, this is the the MP1 is an A7. Yeah, so it's like up there. Quick Connect, Renaissance. Here's another U5. The U5, I think, is like that one that's just like kind of insane for RAM, like internal RAM. Coral Dev Board, I have one of those. I don't know why it's marked as a new product. Beagle Fire, not interesting. N54. Okay, I'm at 150. I don't care anymore. You've lost me. There's 2 other categories I do like to look at in the same way. One is the FPGA dev boards, so in stock, new products, exclude marketplace. I might actually make an order for those ones because they're that cheap, especially if there's some of the espresso chips. Green Pack. This, I thought this was a feather form factor, but it's not. Tang Primer, Mach X02s. The X02, I've talked about my STEM at G0 project, but the Mach X02 is the one that I want to do that way as well. Like FPGA as a coprocessor. Green Pack stuff. ePhoenix. Hey, look at this one. $14,000. Sorry, I'm not in the military industrial complex or the telecom world. The other one I'm going to check is the RF evaluation. This is where the ESP dev boards hit it. And maybe like the Nordic ones too would be under here. So I'm going to do the same thing here. Sort by price. So you can see like C6, 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 C3. None of those are really interesting. I'm more like looking for some that I don't have. A LoRa unit, M5 stack LoRa, Fire Beetle, C3, Adafruit, Itsy Bitsy, C6, S3, NB-IoT. I was thinking NB-IoT would be something interesting for us to do in the longer term. Let's keep looking. I don't think I'm over my impulse budget. Particle Photon 2. An RTL thing. Thing plus, C6. ST, which I wouldn't do. I'm looking at this column as well. Here's a Arduino NanoMatter, but it's one. We actually do have CircuitPython support for the MG24 series that Scilab's added, I think, but we don't have thread support yet for it. NRF shells, Scilabs. We're in the $28 range. Weird form factor. Asset tracker. Nucleo. Yeah. Not that interesting. S3. I already got like a ESP32 P4. Now I'm like above my impulse buy range. Let's just take a look at, oh, do I not? I added those things in my cart and they're not in my cart? Yes, they are. This U5G9 is just kind of insane, I think, if I remember right. U5, and I've been thinking about getting more into like the video side of things. So it's a M33 and up to 3 megabytes of SRAM, which is just insane. But it's really like targeting, yeah. So, but then that's up to U5 G9, I think is what it was. I don't think I have one. I'd be slightly tempted because I do want us to get into like DSI capabilities eventually. The vector graphics unit can use SVG and vector fonts. Interesting. Large embedded memory. Oh, interesting. The U5 F9 VJ has DSI in a 100-pin package. So that could go on like a Metro or a Grand Central. Where in the world is that part I don't need? Expense account with digikey. Yeah. Oh yeah, it has JPEG codec too. U599 has DSI and 2.5 megs of SRAM. Cost effective. I wonder what cost effective means. STM32 U5 G9. And we're not going to do eval boards, although there's 2 eval boards. Oh yeah, one with that screen and one with the round screen. But microcontroller wise, we're looking at $16 in singles, $17, $19 in quantity. This one is still $10. So it's pretty pricey. Especially like this is kind of like in the class of the P4. Although the P4 doesn't have the memory built in. But yeah, I would, yeah. thanks for letting me go down that rabbit hole. I think I'll leave these in my cart for when I see some of the other new ESPs, like there's a ESP32C5, and there's also a C61 that I don't have yet that I'd like to support. But yeah, so interesting parts, but always kind of too expensive. Yes, but I've been looking at the bottom end of the G0 and the C0 for I want to have a coprocessor that I talk to over I2C. I still want to work on that project. Okay, thank you everybody. It's been a pleasure deep diving with you. I'm glad I could make a little progress and really walk through what I've done. This has been another deep dive. If you want to support me and my digikey buying habits, go to adafruit.com and purchase some hardware there. Who knows, maybe they'll end up being Adafruit products one day that we support with CircuitPython. We'll see. If you want to check out the CircuitMatter repo, like I said, it's github.com/adafruit/CircuitMatter. CircuitPython is the same, but it's CircuitPython, not CircuitMatter. I should be around next week, but as I said earlier in the middle of my stream, we are expecting a child next month. So I will be out after that happens, so don't be surprised. If you would like to be notified when that happens and when I'm out, go on the Discord server. The URL that's here. The URL to join is adafru.it/discord. Ask me, Tan Newt, on there to add you to the deep divers role. So when I disappear, I will do @deep divers, and I'll let you know if Tim's going to be able to fill in for me or somebody else will, and you'll be all up to date. The initial plan is to take just 4 weeks, and then I'll be back for a little bit of December, out for the holidays, and then back in January through half the spring. And then when my wife goes back to work, then I'll take more time off. So the bulk of my leave will come middle of next year, probably summer of next year I'll be out, a lot of it. But yeah, so that's kind of the plan. I said where to go on Discord. I said where to support Adafruit. I hope to see you on the Discord. I'm going to keep plugging away at this Matter stuff, see how far I can get next week. Hopefully I could get to the device type stuff. That'd be great. We'll see how this certificate authenticated session stuff goes, but it should just be a lot of just reading and following the instructions, basically. So we'll see. Thank you all. This channel or another best to request. Jono says, this is totally fine. I will add you right now. Live broadcast chat, CircuitPython dev is totally fine too. Thank you all. It's been wonderful. Have a great weekend, and I'll show you the view outside, and then say goodbye. Thank you all.